Okay, area enclosed by loops. So sometimes they just want us to compute, some area of a loop, or maybe the area enclosed by all the loops. This one, let's just do one loop. All right, so find the area enclosed by one loop of r equals 2 cosine 4 theta. So just looking at the graph here to start, maybe that's a good place to start. See that we do have loops, loop-de-loops. 2 cosine 4 theta. Ooh, yeah, we've got loops, don't we? 8 of them. There's 8 loops altogether, and so of course we want to focus in on one of them, and probably try to stay as close as we can to the polar axis, positive x-axis, xy, Cartesian axis. But anyway, all right. So this is one of 8. So the question becomes, well, how do I get one loop? Well, again, it comes back to something we talked about earlier. To figure out, I mean, it's obviously that area is 1/2 r squared 2 cosine 4 theta squared d theta. That part's obvious. The only sticky little point here, what are those a and b? Are limits of integration. Well, what it comes down to here is, well, first of all, noting to get a full loop here, and it may not be what you think it is, but so that's why we're going to kind of work our way through it. But to get a full loop, I have to go from when I get back to this point, so I'm going from this point all the way back around. Well, in both of those points, the r is 0. So I need to figure out where does that happen? And there's different ways. Different ways of doing it, but you know, this is one way. This is what I'm trying to solve that. One suggestion that they have, all right, is to look at it, instead of looking at it polar, let's look at it just as an xy Cartesian equation. So instead of trying to figure out solving this, which that is one way we can do it, but look at it. Let's graph y equals 2 cosine 4x. Y equals. So in other words, change back on here to Cartesian, or change your mode back. Well, to function mode. And graph that. So y equals 2 cosine 4x. Okay. Now, what I like to do is, depending upon that number times x, scale off, because you still have to figure out, well, which marks am I talking about. But if you play off of that, and so what I'm going to do is I'm going to mark the x scale on the TIs. It's called x scale in pi over 4s. So I go to my window and then say x scale is pi over 4. So if it was 3x, I would do pi over 3. See what I'm saying? And so that gives me some. Okay. And so what this looks like then is this. Baby. And with my pi over 4 marked off, there's pi over 4 right there. Okay. Now, I'm looking for r is 0. When I changed it, it's now y is 0, right? And so y is 0, I'm talking about on this would be x-intercepts. So the r is 0 would be x-intercepts on this. So that's one thing you have to understand. Where are my x-intercepts here? Well, it's halfway between pi over 4 and 0. The pi over 8, and then that would be 3 pi over 8. That would be 5 pi over 8, because this is scaled off in pi over 2s. It's at the pi over 8s.
Pi over 4.
Huh?
It's scaled off in pi over 4s.
It's scaled off in pi over 4s. But the x-intercepts are at pi over 8s, aren't they? Halfway. Now, I'm looking for somewhere where it goes from r equals 0 back to r equals 0. So where would you say that would be?
Pi over 8 to 3 pi over 8.
I could do pi over 8 to 3 pi over 8, that would get it. Or I could start back here, which would be negative pi over 8. This one specifically would be this one, negative pi over 8 to pi over 8. So you see where I get that? So I go from one 0 to the other 0, from negative pi over 8 to positive pi over 8. That's what this one is right here. So that's how I get it. I mean, it's a little bit of work to get there, but I think it's quicker if you do more of these. And there's different ways of getting it, but this is the way this book goes through. All right, well, just getting that is fun. Now we get to do the integral. All right, so it's 1/2, so I square that, it'll be 4 cosine squared 4 theta, right? So go ahead and square both of those. Of course, the 1/2 goes into the 4, so it's just 2. Now, again, we have the cosine squared. We'll run into that a lot. Cosine squared, sine squared. So again, we use the double angle. Now, in this case, cosine squared theta equals 1/2 plus 1/2 cosine 2 theta. Or if I put an x there, might be helpful, because here, instead of x, I've got 4 theta, right? And so what will this be if that's 4 theta? It'd be 8 theta, yeah. So it's 1/2 plus 1/2 cosine 8 theta. So you do 2 times whatever that is. With me there? And so yeah, having that 2 out there is nice, because now it's just 1 plus cosine of 8 theta, right? So this wasn't too bad. That antiderivative is just theta. Now what about this integral cosine of 8 theta? Let's use substitution. U equals 8 theta. Du would be 8 d theta. And so du over 8 is my replacement for d theta. So it's cosine of u, and that's du over 8. So that's theta plus the antiderivative of cosine, it's 1/8 anyway, times the antiderivative of cosine, which is sine. So it's 1/8 sine of u, but u was 8 theta. And I'm going to go from negative pi over 8 to pi over 8 for that. So some good stuff. So you got pi over 8 plus 1/8 sine of 8 times pi over 8. Hey, that's going to work out nice. 8's will cancel, so it's just sine of pi, which is 0. Minus negative pi over 8 plus 1/8 sine of 8 times negative pi over 8. So that's going to cancel the 8, so we're going to cancel again. So it's sine of negative pi, but in both cases, sine of pi, sine of negative pi, those are both 0, aren't they? So you got pi over 8 plus pi over 8. 2 pi over 8, pi over 4. That's what I get. Let's see if yeah, that's what I got previously too, so we'll call that good. Any question? Well, now, so that's one loop. If I wanted all of them, the area of the entire loop, all of the loops, well, it was 8 loops, and so I would just multiply that by 8. So get one loop multiplied by 8. So that's what we're going to do in this next one, is just find the area of these loops total. And we'll do another one just to get the process here down. So this one's find the area enclosed by R equals 2 times sine of 3 theta. So in other words, find the area of all the loops, which this one, I believe has 3. Go back to function mode here. Forward mode, yeah. 2 sine 3 theta. 3 loops. Well, bad drawing because they're all symmetrical. The way we're going to do it is just do one loop and multiply by 3. Okay, that's the easiest way to go about it, I believe. So this area enclosed is going to be 3 times the area of one loop which is 1/2 2 sine 3 theta squared. We square that, d theta. The only question then, Mark, is what are my limits of integration from where to where? Well, again, may not be what you expect. And so, yeah, we want it, again, to get one loop, we would go from this r equals 0, that r equals 0, which, again, if you do it in y equals sine of 3x, you can just look at the x-intercepts, go from one x-intercept to the other x-intercept right there. So back to mode, function mode, y equals 2 sine of 3x. And in this case, I would put my x scale where? Well, since that's 3, I would do pi over 3. Just do pi whatever, divided by whatever that multiple of x is. So scale, x scale pi over 3. We should be able to figure this out. Oh, it's right at the pi over 3's, isn't it? It's at pi over 3, and then 2 pi over 3. 0. So one loop would be from one to the other. So you have your choice here. I think the obvious choice would be 0 to pi over 3. But so that one might be what you would guess, but it's not always what you might guess, especially on the cosine. But anyway, is that okay? See where we got all that? we just go from one x-intercept to the other x-intercept, because that's where r is 0 to the other r equals 0. Not too bad. Okay, well, that turns into what? 3 times the integral 1/2 times 4 sine squared 3 theta. So this is our counter with a sine squared. Well, to do us, well, that cancels the 2, so let's leave that 2 there because I think it'll help us out. Yeah, so it's a sine squared, very same idea as cosine squared. Use the double angle, except sine squared x is 1/2 minus 1/2 cosine 2x, right? But in this case, the x is not x, it's 3 theta. And so this would be 2 times 3 theta, 6 theta, right? So it's 1/2 minus 1/2 cosine 6 theta. And again, that 2 helps us out because that'll just make it 1 minus cosine 6 theta. Well, that, again, that's an easy antiderivative, that's just theta. This is just a little u substitution, the minus cosine 6 theta d theta. Just a u substitution, u equals 6 theta. du equals then 6 d theta, so du over 6 is my d theta. So that gives me theta minus, it's going to be cosine of u times d over 6, so that's just 1/6 cosine of u. All right, so we got 3 times theta minus 1/6. So we've got cosine, the antiderivative is sine of u, but u is 6 theta. And I'm going to do that, go back to my limit 0 to pi over 3. Oh yeah, things can work out pretty nicely. Theta is pi over 3, so it'll be pi over 3 minus 1/6 sine of 6 times pi over 3, and then 0 like that because didn't quite get myself to do that. Move my stuff over a little bit. It's sine of 0, right? I can't read that. That's 0. What's this? 2 pi? What's sine of 2 pi? That's 0. Okay, so we wind up with 3 times pi over 3. Those are zeros. Everything else is zeros, right? Just pi over 3. 3 times pi over 3. So one loop is pi over 3. All 3 loops is 3 times pi over 3. It's pi. Yes?